Hi, everyone, and good evening. I'm Dana Thompson, the director of the Brown Planetarium here at Ball State University, and I'm joined tonight with our Constellation crew members. Tonight we have Melanie. Hi, Melanie.
Hi.
We have Greg. Hi, Greg.
Hello.
And we have Caleb. Hey, Caleb.
Hey.
And we also have Nicolette helping out in the chat. So if you have any questions for us during the presentation or answers to our questions during the presentation, you can just put them there and Nicolette will get you sorted out there. So this evening, we're going to start off in a little bit different of a way than we've been doing here in the Constellation crew. And we're going to look at this really interesting picture, and the crew members are going to be seeing this for the first time. But before we get into that, I just wanted to let everyone know that we are still doing our crowdfunding campaign. So if you're able to help support us during this time, just go to the crowdfunding link in the description for the video here and click on Give. So many people have already given, and thank you so much to everyone who has given to the cause, and also to anyone who has just shared our posts on Facebook, because that really does help spread the word and get more people interested in our astronomy programs here. All right, so we're going to switch over to that picture. This picture right here. And I want the crew members here to find or see if you can figure out what this is. What is this a photo of? And it is an object in our solar system. And I know it could be many different things, but it is an object in our solar system. And you can ask me questions to try to narrow it down. And if you think you know what this is and you're watching out there in Facebook world, you can go ahead and put it in the chat.
What type of image is it?
What type of image is it? Okay, so it is, ooh, that's a hard question to answer. So, right, like our eyes, we can pick up visible light with our eyes. We have color receptors in our eyes. They have the ability to detect red wavelengths, green wavelengths, and then blue wavelengths. And we can see the world around us with that information. This is not a photo or an image taken with visible light.
Mhm.
It isn't really taken with light as much of energy, which, you know, is kind of similar, right?
Mhm.
But I will say that it is an object in the solar system that you can see during the daytime. So that should narrow it down quite a bit.
Is it in the inner solar system?
It is, yes. Excuse me. While you're thinking about it, Chris in the chat said to play the black hole music video. So if you remember the black hole music video from the Planetarium programs here at Ball State, you know what he's talking about, or what they're talking about. Someone's saying a solar flare, so close. It is related to the sun. So this is an image or representation of the sun, but not the whole star. And I will say also that this photo, even though you can see the object in it during the daytime here, this photo was taken at night. How would that be possible? This is an image of the sun. How could it be taken at night?
Is this an image of an eclipse?
Excuse me. Is this a image of an eclipse? No.
Well, part of an eclipse. No.
Well, I mean, there is something blocking the sun when this image was taken. So it was taken at night. It was taken on Earth. It wasn't taken from like a spacecraft or a space telescope or anything like that. So Earth was in the way when this was taken. So this must be like, you know, like I said, it's not visible light. It's another kind of form of matter that is going through the Earth that we can collect and put into this kind of image here and represent the sun. So what kind of things go through the Earth?
Neutrinos.
Mm-hmm. Neutrinos. Anything else? Maybe some other particles once in a while. Mostly just neutrinos, right? So neutrinos, yeah. So this is actually an image of the sun taken at night with neutrinos. They traveled through Earth to reach a detector 1,000 meters underground,
Wow.
which I think is pretty cool. Like, so it's an image of the sun taken at night with neutrinos. So again, or for people who don't know, a neutrino is a neutral subatomic particle. So the world's, all of the matter in our world, our universe, that we really are familiar with, it's made of atoms. So what are atoms made up of? Crew here.
Protons, neutrons, and electrons.
Protons, neutrons, and electrons. Are electrons made up of anything else?
No.
No, they're elementary particles. They can't get broken up into any smaller bits of matter. What about protons and neutrons?
Yes.
Yeah. So what makes up protons and neutrons? If we split up protons and neutrons, which are two different pieces. So if we split up like a proton, what would be inside of it?
Quarks.
Quarks. Okay, so there's even smaller pieces of matter than a proton, and that's quarks. What about neutrons? Same thing.
A proton and a neutrino is what it decays into, right?
Well, like inside of a neutron, you still have quarks too. So protons and neutrons are both made up of smaller particles that we call quarks. Yeah. But then there's also neutrinos out there. They are really, really small. They're very, very, very light, right? So how light are they compared to an electron? They're 1.5 million times lighter than an electron. 1.5 million times lighter than an electron, neutrinos are. And they're 10 billion times lighter than a grain of sand. So they're very, very light. They don't really interact with matter. They can go right through it usually. But there's a detector that is under a mountain in Japan. I hope I'm pronouncing this right. Mount Ikano. Mount Ikano. So there's this detector down there that can sense these neutrinos, and basically they have a whole bunch of detectors that are surrounded by water. And when a neutrino kind of hits a water molecule in just the right angle, at just the right angle, it gives off energy, gives off this little bit of light. And there's these bulbs surrounding it. They kind of look like light bulbs, but they work in reverse. So with a light bulb, you have electricity going in and light coming out. These detectors that are in this observatory, they take in energy and they send out light that we can represent. Okay, so this is not just the whole sun, though. Let's see. This is from a Twitter post. Twitter has some of the best science posts out there. So Professor Paul here says that this is an image of the sun taken at night with neutrinos traveled through the Earth to reach a detector 1,000 meters underground. It was taken, so, he put that in quotes here because it was taken over 503 days with the Neutrino Observatory under Mount Ikano in Japan. So as we talked about, Earth is essentially transparent to neutrinos, which do strike those water nuclei electrons and emit this type of radiation that is then detected by those kind of light bulb-like devices that are called photomultiplier tubes. So getting kind of fancy here. But basically, this isn't the whole sun. It's just a solar core where there's a lot of fusion taking place. So in our sun, hydrogen fuses into helium. And so where that is happening, neutrinos are produced, and it can take a long time for photons or light to escape that interior. It's so dense there, the photon kind of gets bounced around quite a bit. It interacts with the matter there, and it will take over 100,000 years for it to actually escape the surface of the sun, making its way to Earth. How long does it take that light to get to Earth, crew? So once light does exit the surface of the sun, how long does it take to get to the Earth?
8 whole minutes.
3 minutes.
8 minutes.
Yeah, 8 minutes. Yeah. So once it's out, it only takes 8 minutes, which I think is pretty pretty amazing for it being stuck there for 100,000 years. But neutrinos just punch their way out of the core in 3 seconds, which is quite impressive. All right, then they zip to Earth, and thousands pass through our body all the time, but we're okay. I hope. All right. All right, so we're gonna kind of go back to how we usually start our programs with just a sunset here on campus. You might recognize some of campus here. The sun is setting over in the west as it should, and then we're gonna kind of fly out into space, leave our atmosphere behind, and see a beautiful night sky, and look kind of towards the south, or where south would be in our sky, or where the stars would be in our sky in the south at this time. And Melanie, you're going to take it from here, I think, and kind of share this constellation that we're going to be exploring tonight.
Yeah, so you saw from the title, tonight we're going to be exploring Auriga. Am I saying that right?
Auriga.
Auriga, okay, that's a tricky one. So we are going to do like a quick review from a couple weeks ago. Like we said, using Orion's belt is extremely useful in finding many, many constellations. So that's always a good place to start. So we're going to go ahead and see if we can find Orion's belt. And from there, we're going to go straight up. You see Taurus, which we explored last week. And if we go to the very end of the horns of Taurus, you might see something that looks a little bit like maybe a house or a little pentagon shape.
It looks like an upside down house to me.
Yeah, me too. Maybe it's Taurus's house, but I don't think he can fit in there. And so it looks
might be
like,
a little too big.
yeah, it looks like it's actually a part of Taurus because there's that star connecting the two of them. But as we learned last semester, you can't have any stars within two constellations. So the one that's a part, or appears to be a part of Auriga, is actually a part of Taurus. So again, no two stars can be in different, or one star can't be in multiple constellations. So if you look to your west or northwest, you're going to look for Auriga, our upside down house. And a part of Auriga is this big yellow star named Capella. And you think, cool, a big yellow star. That sounds familiar, but it is really cool because it's actually 4 stars all in one.
Wow.
So we have 2 binary pairs actually. So the 2 larger stars are yellow, about the same temperature as the sun, but about 10 times larger. And those are the stars that give Capella its yellowish hue to us anyway. And the other 2 stars are 2 red dwarf stars. So those 2 are both their own binary pairs. And a part of Auriga is another asterism, which again is just another little shape we can make in the stars that's not technically a constellation.
Before we go off to that asterism, let's look at a group of stars, another kind of cluster of stars that we explored last week, and how to find it. So we can really then highlight Auriga there for friends watching. So if you remember a couple weeks ago, if you were watching with us, if you weren't, that's okay too. If you use Orion's belt, follow it upwards past the V shape for Taurus Bull, you can get to this little tiny cluster of stars here, the Pleity star cluster, which is a multiple star system, but there's so many stars there, over 1,000, that we call it a star cluster. And it looks more like probably just a little smudge on your screen, but in the real night sky, it looks quite impressive. We really highlighted that the other week, but we're on to this other constellation here, as Melanie said. And we have these constellations that help us map out the sky, but we also have other things like asterisms. So Melanie, you're explaining what those were.
So yeah, just a smaller little pattern within the constellation of Auriga is called the Kids, which is sort of a play on words because Auriga is known as the charioteer or the goat. So the Kids is just another name for baby goats, actually. So there's this tiny little triangle shape if you look up near Capella. And if you're not sure you found Auriga, you can also use, this asterism to double check and make sure you did find it. So you'll see this itty bitty little triangle, and that's what we call the Kids. But I did see a couple pictures that actually had one Below that was known as the little kids, so even smaller, even cuter, little baby goats.
This is
And
just so
it's the same
cute.
shape. I know, it's just another triangle. So there's the regular kids and then the little kids. So I guess you can decide if you're with the cool party or not, the kids table. But if you are able to see those two little triangles, you know that you made your way to Auriga correctly.
Yeah, because I sometimes get it confused with this group of stars over here. This is another constellation we're going to be exploring next week. This is Gemini the Twins. So sometimes when you come up from Taurus, it looks a little bit like you might end up over in this region, but you want to really make sure to follow the stars up over this way. And really that bright star Capella, which is really 4 stars out in space, not just the one that we see here on Earth. Is really, really bright, one of the brightest stars in our night sky. So if you can find Capella, you know you're looking in the right spot too. And Capella is right by kind of that the kids' asterism there. All right, so if you have a good imagination, you might be able to see what Auriga is, the charioteer. But I don't. I see like a pentagon or a house, upside down house. But we're going to be exploring that a little bit later with Caleb. But now let's actually fly into this area in space, look at a real image, and see what else is there besides the stars that make it up. All right. All right, so let's figure out where we're exactly looking, because things kind of shifted a little bit. And Orion the Hunter is down here. It's kind of your starting point anywhere. Any constellation you're really trying to find in the winter sky, it really helps to find Orion the Hunter, for many of them anyway. So here's Orion. Here's the Pleity star cluster. Here's Taurus the Bull's face. So up to the horn here. So Auriga's over here in the sky. We're going to fly into that area and see what is there. And I think, Caleb, you have some really interesting information about this area in space. So, I mean, like,
Yep.
just really quick, you can see that there's so many stars here. Every point of light here is a star. And we're going to fly into one of them that is quite interesting. Go ahead, Caleb.
Yeah, this is a very interesting star system known as AB Aurigae. It's a very young star that's as compared to other stars that we can see, and it's actually in the process of still in its. You see right here, this is its protoplanetary disk, and we've actually observed evidence that there's a planet forming around this young star.
So this bright area here is the star.
Yep.
And then we have this area here where there's just a whole bunch of gas and dust. That's a protoplanetary disk. But there's dark areas where there's probably gaps forming. And why is that, Caleb?
That's because of the planet that's forming in that system. The planet's basically affecting the gas and dust inside.
Yeah, so
as
gas,
it's forming.
gas and dust is kind of condensing and forming planets around this newborn star. And we're seeing that actually in this picture, which is really amazing, I think, to be able to see this much detail. We've looked at another picture before of a protoplanetary disk last week, I think, right, crew? And there were like gaps in the disk too, but they're really round and like circular. These are more spiral shaped. Do you know why there might be a difference?
I only have
I can only guess.
Yeah, I mean, like I did a little bit of research on it. So again, like why is this protoplanetary disk, this newly forming solar system or star system, because solar is just referring to our sun, really. So this newly forming star system, it looks spiral. But we looked at another one the other week ago, and it was very, like the orbits of the planets were really well defined, very circular or elliptical, really. Why the difference? Why do you think? I didn't find that much information, but I have a guess too. But what are your guesses first?
The only thing I could think was sort of how I think one of Mars's moons is kind of spiraling inward, or they think it might be. So maybe the object was a little bit too massive, and so like the effect of gravity was pulling it in.
So there
And
might
it
be
couldn't
some
stay in
migration or
orbit.
something.
Yeah,
That's a lot of migration going on.
that's true.
Yeah, I don't know. That's amazing.
Caleb, you said you had a guess.
I think it's possibly due to the rotation of the disk. I mean, that could be possibly.
Yeah, maybe it's more violent or something. And that kind of relates to what my guess is. I have a pretty simple solution, I think, than the two guesses that were shared out just now. I think maybe this is just younger, and so we're seeing the planets forming earlier. They're still defining their orbits and really taking in material, whereas the one where you could really clearly see the orbit lines, they've been forming for a while. They have been clearing out their orbital paths for quite some time. So I just think that this is maybe a younger system. That's my guess.
It's always the simplest answer.
Yes. Yeah.
I've learned to trust that.
All right. But there's more. There's more in Auriga. And so Auriga, again, is over in this area in the sky. We had Capella, which is the brightest star in it, which is actually 4 stars. And we're going to travel to a star in the middle of this area here and watch the stars all change locations, because we're going to be traveling a large distance here in the simulation. And we can see stars passing by on our way here. Melanie, how likely is it that there are other multiple star systems out there?
So it's really, really likely. I think the majority of stars have at least 2, but the most common number, for whatever reason, is usually around 3. So we say, okay, what is a star system? It's a small number of stars that orbit one another. But as we learn in astronomy, like our adjectives don't mean anything. Small, large, hot and cold. Like, so what does small mean? So we know that it's like anywhere from 2, which is like a binary system, to 1,000 or 100, which is where we usually start to call it a star cluster. So it's sort of a matter of, okay, well then are star clusters technically star systems? Technically, yeah, I guess. But that's just a whole nother argument that people are trying to sort out. But yeah, 3 is the most common that we see for some reason, where these stars are gravitationally bound in some way. They behave pretty similar to star clusters. There's just significantly less of them. And it does make them a little bit harder to study because it's harder to find them. And so some of these star systems have many stars that are kind of interacting or exchanging materials, but that doesn't mean that all of them are like that, or all of them are gonna, merge together and just kind of blow up. Like some of them are kind of off doing their own thing. They're pretty consistent. It seems kind of boring. They're just doing their own thing, kind of orbiting around one another. I think a lot of people think that the sun might actually be a part of one. So maybe if you were on a planet around one, you wouldn't even know it. If the star was far enough away, you couldn't really tell there was any kind of interaction, at least for a really long time. You'd have to study it. But just because some of them are interacting or exchanging materials doesn't mean that they all are. So it is possible to host planets because some of them are relatively stable or just existing. So again, maybe you wouldn't even know that you were a part of one. So if materials from stars combined or 2 small enough stars combined, you might see one of those planetary disks like you saw Caleb talking about, where planets could maybe form. But there's a whole bunch of other ways that they can form. But regardless of how they form, they are forming. And we have proof of that because we have actually found some exoplanets. And I think Greg has a really cool one to talk about.
Yeah, so one of the star systems that's in Auriga is HD 40979. It doesn't have a cool fun name or anything like that, but it's a triple star system, and there's actually been a exoplanet confirmed around one of those stars, and that's what we're seeing on the screen right now. And if you're wondering what that kind of green disk is that's around that star, is it's actually the habitable zone for those planets, right? So the Earth is in what we call the habitable zone around the sun. So it's where it's not too hot, so it's not too close to the sun, it's not too hot, it's not too far away, it's not too cold, it's just right. And we call that the Goldilocks zone. And so the really interesting thing about this exoplanet that was found is that it's just on the edge of what you can see there, that green disk, just right on the edge of it. So it could potentially be in that habitable zone. We don't know. That doesn't mean that there's life or anything on it. Mars is technically in the habitable zone of our sun. So, but it's just really interesting, really cool that there is that exoplanet that we've confirmed around one of those stars.
Yeah, and just because it looks a little confusing, this is the exoplanet, the planet going around another star in our galaxy, outside of our own solar system. That's not a star. This isn't a multiple star system. This is an exoplanet going around the host star here, which again it has a really dramatic name. Not so much. The HD 40979. Doesn't have a cool name, but there is a planet going around it. We know that for sure. And every star has this habitable zone, this area where liquid water could exist and maybe support or sustain life. But you need the right conditions on the planet in the first place to even be able to support that, even if it is in the habitable zone, right? And do you remember, Greg, what type of planet this is?
I do not remember.
Is it like a gas giant, or is it a terrestrial planet, like one we could land a spaceship on, that we're on right now with Earth? Because that matters, right? like that really
Yes.
affects how we would be able to search for life on this exoplanet. Because if it was a rocky planet, we'd be like, yeah, let's, it's close to the habitable zone. Maybe we want to look into this more. But if it's a gas giant, we haven't found anything. We don't expect to find anything on something like that. So it is.
You know what method they used to find it?
Yeah, what method did they use? I wonder.
Yeah, I don't know.
Yeah, I wonder if it's they'd have to have a couple methods to really understand its orbital period, how it kind of interacts and goes around here. So probably maybe multiple methods, but transit is one of the most common. So when we actually see the exoplanet transit or go in front of its host star, and as a result, we see that starlight dim a little bit. And because we actually do know what type of planet it is, if it's rocky or if it's a gas giant, that tells me that we have to have another method that we used. Because if you know what type of planet it is, you know its mass, and you know its volume or its size. And to get both of those pieces of information, you need to see a transit, and you also need to see the Doppler, Doppler shift method.
Doppler shift.
Yeah. I don't usually talk about that one, but you need both of them to be able to get the density, basically. And the density tells you what type of planet it is. And this is a gas giant planet. So this exoplanet here in the star system in Auriga, it's probably nowhere we're going to find life because it's a gas giant planet, even though it is by this green ring here, the habitable zone in this area in space. Quite amazing. Ooh, let me back up just a little bit. Before we go on to even that beautiful purple picture there, you can look around here. I think that this is Orion. I think this is Betelgeuse, the red star in Orion the Hunter. But we don't see Orion in this area anymore because we're like thousands and thousands, trillions of miles away. Many, many trillions of miles. Light years is what we usually say now in astronomy when we go these large distances. So we don't have the constellations we're even familiar with in this sky here, but we have the same stars because we're all in the Milky Way galaxy. The stars we see at night are a part of our Milky Way galaxy. They're just seeing them from different perspective here. So we have to make up our own constellations. This kind of looks like a dolphin or something. I don't know. I just like the dolphin
Oh, one's a dolphin.
constellation.
To me, it looks like the Empire State Building.
Yeah.
Okay.
Looks like a wonky Christmas tree too, with the little Christmas light on the top.
It's like a little
Oh
rocket.
yeah,
A
It's kind of
rocket,
like a
yeah.
shark fin too.
Mm-hmm.
You just take the like 5 stars there, kind of
Yeah.
looks like a shark
if
fin.
look
coming
there
along.
over, if
Yeah.
you look over in the far left, it looks like a slanted box.
A fox?
Yeah, over there in the far left.
I don't see it. But we like to make pictures out of things in the sky, right? We have our constellations we do that with, but there's other things we make pictures out of all the time in astronomy. And one of those things are nebulae, clouds of gas and dust in space. And this is a nebula that's in the constellation Auriga that we've been exploring today. It's really beautiful, I think. There's lots of stars in this picture, and then you can see this color here. That's the gas and dust being lit up probably by this bright star here in the middle. So this has a name that is similar to what it looks like to some people. It's called the Flaming Star Nebula. The Flaming Star Nebula. I usually see the same nebulae all the time in pictures and stuff, because there's some really popular, famous ones that are just everywhere. And you go out and you can see so many more though. Like, and this is a new one to me. I have not seen this one before. I started studying for this program tonight, but it's beautiful. It really is. And this does look like a Christmas tree too. It is not Christmas anymore.
No.
It is Valentine's Day.
It is
So
not.
it is almost Valentine's Day. So we
It's
got to kind of make a
around.
heart out of this.
There's still snow on the ground outside here. It's
Yeah.
fine. It's
Yeah.
still Christmas.
Yeah, still good. I mean, we might not throw out Christmas tree until like February sometimes, end of the year.
Well, like, okay, so Christmas tree, I can see that being up all winter.
Winter season.
Yeah, I mean, you have to take off the ornaments that are related to to Christmas though, like Santa and stuff. Like he has to go, right? He's out.
Goodbye, Santa.
Hey,
But
no
like
one for Santa here today.
I would leave. We have snowflakes that we usually put on the windows in the planetarium lobby, and I would leave those up, until the end of February. But usually at the beginning of February, everyone's wanting to put up hearts, and snowflakes are over with. And I finally kind of understood the social norms that go along with these decorations that I just didn't get for the longest time. So at the end of January, snowflakes were gone, and then that's when it started to snow here in Muncie so much.
Yep.
All right, but we're talking about space and astronomy, not the weather. And we were focusing on the constellation Auriga. So here's another depiction of Auriga, the charioteer. And there's the kids. There's a whole story behind this. I'm not familiar with it. And all of my schooling and everything, I was focused on physics and astronomy, the sciences. I did not get into the stories. I know a little bit because you pick them up over time. Pick it up on the streets, they say. So I do know a little bit, but I don't know much about Auriga. I think Caleb's going to help us out with this part.
Yeah, with Auriga, there's different stories depending on what story you're reading. But one popular story is that it was that the charioteer was corresponded to this guy known as Erechthonius, who was a king, and he was the son of the god Smiths, Hephaestus. Apparently, according to the myth, he was raised by the goddess Athena, who taught him many things, and he was the first person to tame and make a chariot with 4 horses. And Zeus was so impressed with his skills that he placed him in the stars.
He's got some mad boots here.
And, yeah, and also with the goat on his shoulder. I think that's signifies the Capella, right? Capella
Capella's here.
actually is Latin, I think, for she goat, and is attributed to the goat who raised Zeus when he was a baby.
Wait, a goat raised Zeus?
Yeah, yeah. She was his foster mother after he had to escape from being eaten by his father.
How does a goat raise a kid? Like
He was
like a
pretty
real, like a
successful.
human kid, not a baby
These were
goat
gods.
kid.
Well, you mean like Zeus's own daughter Athena sprang from his head, you know? So you
There's
tell
no
me how
goat.
a goat raised.
There's no
I mean, the founders of Rome were raised by a wolf, so why not a goat?
That's true. The founders of Rome really were raised by wolves, according to their mythology.
Okay,
Interesting.
that is really interesting. I like that. Okay. All right, yeah, this is the bright star Capella, represented by this goat here, because Capella is Roman for female goat or little goat, I think. Either one. Take your pick. And then we have the kids down here, the asterism here that we saw before, and then what, the baby kids, or what was it, Melanie?
The kids and the little kids.
The kids and the little kids, they're all up here too. So this is right by the constellation of Taurus, the bull, which we explored last week. Any final thoughts, crew, on our constellation of the week before we wrap things up? Something's happening next week on the 18th. What is it? It's really exciting.
Mars.
Perseverance. Yeah.
Mars is happening.
Perseverance.
Yeah.
Landing on Mars.
Perseverance, the Mars 2020 rover, is landing on the red planet on Thursday, the 18th next week. You need to watch it live on Facebook or live on NASA Live or NASA TV, I think it is. We'll post the information in the chat here. Nicolette will get you some information about Perseverance, the Mars 2020 rover that is landing next week. So that's really exciting. Don't miss that out, or don't miss out on that. And we're going to be sharing information about that on our Facebook page. So if you just are following us on our Facebook page, you can stay up to date on the Perseverance rover. All right, final thoughts, crew? No, Melanie, you want to end the program tonight with just a shout out to our donors and give some folks some information about our crowdfunding campaign?
Yeah, so we're still working on that. We have 16 days left, and another big thank you to everyone that donated. If we look different tonight, it's because we're using our new webcams and lighting, which has been really, really helpful. So thanks to everybody that made that possible and to everybody that shared. And again, if you are able to donate, we think the link is in the link to the video as well. So thank you guys.
Yeah, thank you everyone who has supported the Planetarium beyond the crowdfunding campaign just by watching us tonight. We really appreciate it. And if you do have any questions or anything for us, put them in the chat. We'll check it out and get answers to that later. But thanks so much for watching, everyone. Have a great rest of your evening and a wonderful weekend. Stay safe.
Bye.